Hello everyone. This lesson we're going to start talking about power factor correction in three-phase system. First, we're going to review a little bit for the motor. Motor is an inductive load, so motor will causing lagging power factor. The horsepower rating of the motor is the output power of the motor. So motor is rated in horsepower, but that horsepower is the output power from the motor shaft. The percent efficiency of the motor is the output power divided by the input power times by the 100%. So the input power is the electrical power input, the volts, the current on the motor terminal. The power factor. The power factor we know is the input power divided by the kVA. That gave us the power factor of the motor. So here's an example. I have a 600 volt three-phase 30 horsepower motor. The efficiency given to you for this motor is 80%. The power factor at the full load is 70%. The question asks you to find out the line current at the full load and to find the kVA rating of a three-phase capacitor bank to correct the power factor of this motor to the unity. Here are the steps we're going to take. First, for the motor, the output power we can find out first. The output power 30 horsepower times 746. That's 1 horsepower equal to how many watts? We get 22.3 kilowatts. Once we find the output power, we can base on the output power with the percent efficiency, find the input power. Input power equal to output power divided by percent efficiency. 22.38 kilowatts divided by 80% gave us 27.96 kilowatts. That's the input from the electrical connection on the motor terminal. Now we can calculate the total kVA of the motor. kVA equal to input power over the power factor. 27.96 kilowatt, that's our input power. Power factor 70%. We got a 39.96 kVA. That's the total kVA from the line side. From the total kVA, we can calculate the line current. The line current is going to go equal to total kVA divided by root 3 divided by line voltage. So 39.96 kVA divided by root 3 divided by 600 volts give us 38.46 amps. That's the line current. When motor deliver the full load, the motor is going to draw this line current. To find the capacitor kVARs, we have to find out how many kVARs the motor has. We learned in year 2, the formula to find the kVARs is equal to VA squared, subtract power squared, take the square root. We put the number, the kVA, the input power in there. We find the motor have 28.1 kVARs. The motor is inductive load, so those kVAR is lagging VARs. To correct the power factor to unity, we put a capacitor bank in there. The capacitor bank we have a leading VARs. So the capacitor bank needs to supply the same amount of lagging VARs so we can have a unity power factor. We know the motor have 28.1 kVAR lagging. We supply 28.1 kVAR leading by the capacitor bank. So when the lagging VARs equal to the leading VARs, they cancel each other out because they are opposite direction. Now we only have the true power for the motor. That's when we power factor to the 100% or unity power factor. The three-phase capacitor bank, we can connect them in two different ways. To connect Three-phase capacitor bank for high voltage application, we usually connect the capacitor in Y connection. Because we know for Y connection, the phase voltage is going to be line voltage divided by root 3. So the requirement for each capacitor will be, the insulation rating will be slightly lower. So when we connect them in Y, the line voltage could be root 3 higher. Or we can connect capacitor bank in delta configuration. We know in delta configuration, the line current is going to be root 3 higher than the phase current. So when we connect capacitor bank in delta, the requirement for capacitor to handle the current will be slightly lower than root 3 lower than the line current. Here, the first part of power factor correction. The next lesson, we're going to talking about more detail. If you have any question, connect us online or send us an email.